Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hyperconjugation involves the overlap of CH sigma bonding orbitals with an adjacent vacant p orbital, or pi system. The number of CH bonds available for hyperconjugation equals the number of hydrogen atoms on the carbons directly adjacent, alpha, to the carbocation center. Moving on to the next step. Draw the ethyl carbocation. The ethyl carbocation is CH3, CH2+. The positive charge, vacant p orbital, resides on the terminal carbon, C1 the carbocationic carbon. Moving on to the next step. Identify the carbon adjacent to the carbocation center. The only carbon adjacent to the positively charged carbon, C1, is the methyl carbon, C2, which is CH3. And for the final step, count the CH bonds on the adjacent carbon available for hyperconjugation. The CH3 group has 3 CH bonds. Each of these sigma bonds can align with and overlap into the vacant p orbital on the adjacent carbocationic carbon. Evaluate why other options fail. A. 0, incorrect, because hyperconjugation does occur in ethyl carbocation. C. 5, incorrect, this would imply all CH bonds in the molecule participate, but only adjacent CH bonds overlap with the vacant p orbital. D. 6, incorrect, ethyl carbocation only has 5 total CH bonds, 3 on CH3 and 2 on CH2+, and the CH bonds on the carbocationic carbon itself do not overlap with the vacant p orbital in the same hyperconjugative sense. Only the 3 CH bonds of the CH3 group, alpha carbon, are available for overlap with the vacant p orbital on the carbocationic carbon. Therefore, the correct answer is B. Therefore, the correct answer is option B.